Okay, so we've had a couple other questions here that I'm going to go over. So this is from 4.7, number 40. And what we're looking at here is doing a limit. So what we'll see here, we have the limit as x approaches 0. Go away. Of 1 plus 4x to the 3 over x power. So this is, of course, problem doing L'Hopital's rule, and we have to make sure that we're in a correct form here. And if we plug in 0, of course, we would get 1 is what this would be inside. And then you think 3 over 0, well, 3 over something, that's going to go off to infinity. So this is 1 to the infinity power. And so, of course, we need to, again, do our y is equal to the limit as x approaches 0 of 1 plus 4x to the 3 over x. And then we take the natural log of both sides. Over x. Well, here, that's wrong. Let me erase that. Sorry. So we have, I was trying to do too many things at once here. So we take the natural log of both sides, and you'd have the limit as x approaches 0, the natural log of 1 plus 4x to the 3 over x. Then you do the natural log, and then you would bring that down in front. But then again, because this is already 3 over x and you bring it down in front, you actually don't have to rewrite everything because you've already now got it in a nice form for yourself. And if you think about this for a second, well, what's inside here is going to go, well, the 4x is going to go to 0, but what's inside there is going to go to the natural log of 1, but that is equal to 0. So my form is 0 over 0. So I can apply L'Hopital's rule directly to this. So you'd get natural log of y is equal to limit as x approaches 0 of 3 times 1 over 1 plus 4x, of course, times the derivative of 1 plus 4x, and then this is all divided by, well, the derivative of x is just 1. Limit as x approaches 0. Let's clean this up some. So I've got 3 over 1 plus 4x. And then derivative of 1 plus 4x, that's just simply 4. So we'd have 12 over 1 plus 4x, which 12 over 1 plus 4x, this simply just goes to, limit as x goes to 0 of this, that would just go to 12. Then remember, we're looking for y, so y would be e to the 12th. So again, what we've just determined here, the limit as x approaches 0 of, what was my original problem? 1 plus 4x to the 3 over x is equal to e to the 12th power. So same section, number 45. X approaches 0 from the right of the tangent x to the x power. So this is another L'Hopital's rule. This is actually, if we think about this for a second, this is in the form 0 to the 0. So again, we'd have that natural log of y is equal to the limit as x approaches 0 from the right of the natural log of the tangent function to the x power. So you have limit as x approaches 0 from the right, pull down that x, natural log of the tangent function, and then we'd move that x into the denominator because this is in the form 0 times infinity. Because remember, we leave the natural log in the numerator. And then we just have to continue on here. Now we're in the form of, well, what would this form be? Infinity over infinity. So we can apply L'Hopital's rule. Which would be 1 over tangent x times the derivative of the tangent function over x to the negative 2. And so this would be natural log of y is equal to limit as x approaches 0 from the right. Derivative of tangent function is secant squared over tangent over x to the minus 2. So before we try and do any kind of evaluating limits or anything like that, we should really try and simplify this sum and see what we get here. So what do I mean by simplify? Well, let's look at secant squared x over tangent x. Because we know that secant squared is 1 over cosine squared divided by sine x over cosine x. Well, that would be 1 over cosine squared times cosine over sine x. Okay, so that would give me one over cosine x times sine x. Alright, so then let's go back to what we have here. So we have the natural log of y is equal to the limit as x approaches 0 from the right of 1 over cosine x sine x over x to the negative 2. So let's also rearrange this a little bit more. X squared over cosine x sine x. And if we think about this for a second, this would be in the form 0 over 0, so we could apply L'Hopital's rule again, but before I do that, I'm going to remember a trig identity. That sine of 2 theta is 2 cosine theta sine theta. Because what I'm going to do here is I'm going to rewrite this. So limit as x approaches 0 from the right of x squared. Now, it would be 1/2 sine of 2 theta, which would get me the natural log of y is equal to the limit as x approaches 0 from the right. I mean, you don't have to do that trig identity. You could use the product rule and do the derivative here. Maybe I'll do that in a second and show you that you can still get the same answer if you didn't use the trig identity. I'm going to move that 2 into the numerator, so I'd have 2x squared over sine of 2 theta. Now I'm going to apply L'Hopital's rule, so I get 4x over 2 cosine of 2 theta. And believe it or not, I can finally plug in 0. And I started writing these as thetas. These should be x's. Don't know why I wrote those as thetas. But we can finally plug in, as I said, we can finally plug in 0. So you'd have 4 times 0 over 2 times cosine of 0, which is 0 over 2, which of course is just 0. So the natural log of y is equal to 0, which means y is equal to e to the 0, which is 1. So after all of that work, we get that the limit as x approaches 0 from the right of the tangent function to the x power is equal to 1. Now let me back up here, and I'll go ahead and do, if you don't, because a lot of you probably say, well, I'm not going to remember that trig identity. So what? You can still do the problem. And we have x squared over, I'm going to write this as the sine function times the cosine function. So we know we can still apply L'Hopital's rule right as it is right here. So we get limit as x approaches 0 from the right of 2x. Now I'm just going to write I'm not going to write the product rule out. I'm just going to write what we'd get here. So we'd have derivative of the first, so derivative of the sine function is cosine, times cosine. And then I'd have plus sine times the derivative of the cosine, which is negative sine. So you'd get the limit as x approaches 0 from the right of 2x and I can't draw my lines right now. There we go. Over cosine squared x minus sine squared x. So that's saying, oh, I didn't remember the trig identity. Okay, I didn't remember it. Still could do a derivative. Still going to get the same answer. Because if I plug in here, you'd get 2 times 0 over cosine of 0 minus the sine of 0, which is 0 over 1, which of course is still 0. And so, of course, this is natural log of y is equal to that, so we still get the same answer. All right, so that wraps up the questions I had, but since you guys hopefully watched all the way to the end of this video, I'm going to give you a little special treat here. And this is special. I don't normally do this. On the exam, there is one question from 4.4. It is very similar to 4.4 number 23, the flower garden. It is very similar to that problem. No, I'm not going to do a solution of that online. The solution, I'll go here, is right here. So I would definitely look in your textbook at this problem and look at the solution and make sure you really understand how to do that problem. So thanks for watching all the way to the end of the video.